Hi guys, welcome to my channel. In this video, we are going to analyze the questions about the structural analysis. The question will be analyzed due to moment distribution method. Let's analyze the question. First, I'm going to specify the fix and moment. Fix and moment from A to B. W L square over 12. So W is 2. And fix and moment BA, that will be equal to positive of this value. And fix and moment from B to C. 3 multiplied with 24 square over 12. And will be equal to minus 144. Okay. And fix and moment C to B will be positive of this value. So now I have my fix and moments. So let's find the stiffness factors. KBA will be equal to 4EI over 36, EI over 9. And for KBC, 4EI over 24 will be equal to EI over 6. Now I obtain the stiffness factors. Let's find the distribution factors. Distribution factor AB will be equal to EI over 9 or EI over 9 plus EI over 6 and will be equal to 0.4, and I want to subtract 0.4, and you know that this distribution factor, the summation of this both, this one and this one, the summation of both must be equal to 1. Okay, so when I subtract distribution factor BC 0, so BC 0.6. okay, now I have my distribution factor BC 0.6. So I'm going to write, if it is fixed, it is 0. And this one will be 0.4, and this one will be 0.6. And I have my fixed end moment. Fixed end moment here minus 216. And here is 216. And this is minus 144. And this is 144, right? Now I write my fixed end moments. So let's distribute it. How I'm going to distribute? When I take this moment and multiply with its own distribution factor, it's going to be 0. So I'm going to write here 0. And this one, when I multiply it with its own distribution factor for CB, will be 0. And for BA, I'm going to take the summation of this both moment. So it's going to be like that. When I take the summation of them, okay, and when I multiply with its own distribution factor, and I'm going to multiply with the minus 1, okay, and this is going to be equal to minus 28.8 for here. And for this one, it's going to be actually the same, but it's going to multiply it with, it's going to be multiplied with its own distribution factor. So it will be multiplied with 0.6 and multiplied with minus 1. And that will be equal to minus 43.2, okay? And now let's write it. Minus 43.2. This is the moment that I distribute. And now I have to make a carryover. The carryover that will be at this direction and this direction. So this will come here as 0. This is going to be 0 here also. And this is going to be half of this one. Yeah. So that will be minus 28.8 multiplied with 0.5. It's going to be minus 14.4. And this will also be minus 43.2 multiplied 0.5 will be equal to minus 21.6 and minus 21.6. And now I'm going to take the summation of the moments, because now I cannot make any carryover here. Now it's the last row. So I'm going to take the summation of the fixed moment until the last distribution or last carryover. Okay, so now I'm going to take until here, and now the summation of them will be equal to minus 230.4 and 187.2 and minus 187.2 and 122.4. Okay. Now I take the summation all from its own fixed moment until the last row. Okay. Now let's find the shears. Now I have the moments, so I'm going to calculate the shears and draw the shear and the moment diagrams. Okay, so let's find it. For the first part, I'm going to have as A, B, and this is equal to 2304, and this is, I have a moment here as 187.2, and I have a distributed load here that acts in the center of the midpoint of the beam, and this is 18 feet. Okay, this is 18 feet. And the force it acts is 72 kips. Let's find the shears. The total moment at A is equal to 0. This direction is positive. 230.4 minus 72 multiplied with 18, this length, okay, and minus 187.2 plus VB multiplied with 36 equal to 0. And VB will be equal to 34.8. And the total Fy is equal to 0. So I'm going to find the shear at A. 72, I have a distributed load. I convert it to the point load, minus 34.8, and minus VA equal to 0, and VA will be equal to 37.2. And let's do it for the second part. Actually, we can say VB left for this one. And this is going to be B, this is going to be C. And I have a moment here as 187.2. And I have a moment here as 1224. Okay. And I have a force here as 72, because when I multiply 3 with 24, and I'm going to obtain 72, and this is 12, and this is 12, So the total moment at B is equal to 0. Okay, So 187.2 minus 122.4 and minus 72 multiplied with 12 plus VC multiplied with 24, okay, equal to 0. And VC will be equal to 33.3 gibbs, and the total Fy equal to 0. So now I'm going to obtain the other shear, VB right, okay, 72 minus 33.3 and minus VB right equal to 0. VB right, that will be equal to 38.7. Now I have all shears. If I have shears, let's draw the shear and the moment diagrams. For the shear diagram, the first part, I have a shear at A 37.2, okay? So I'm going to raise 37.2. This is 37.2. And you know I have a distributed load. So if it is distributed load here, I'm going to decrease as triangular. So I am going to now decrease as 72. 72 minus 37.2. And I'm going to obtain, this point. I'm going to obtain 34.8. This is A, this is B. And now let's draw for the second part. This is B, this is C. You know, at B right, I have a shear as 38.7. 38.7. So I am going to again decrease as 72 because in the second part it's also 72. And I'm going to obtain 33.3. Okay. And now I'm going to draw the moment diagrams. For drawing the moment diagrams, I'm going to, and I need to know this length. Okay, I'm going to write here x. This is going to be 36 minus x. So when I write an equation like this, over 36 minus x equal to 37.2 over 34.8, and x will be equal to 18.6. Okay, and for this one, let's write as y, and this is going to be 24 minus y. And when I calculate here, y over 24 minus y equal to 38.7, 33.3. From this equation, this rate, I'm going to obtain y as 12.9. Okay, now I obtain the x and y values. So let's draw the moment diagrams. For the first part, I have a moment here as downward, okay, due to the table, minus 230.4, right? Look at here. I'm going to show you. For example, this one, 230.4. So I'm going to down. Okay, I'm going to start with the bottom of the line. 230.4. Okay. And I'm going to increase at this amount of area. When I multiply it, 37.2. Okay, 37.2 multiplied with 37.2 multiplied with 18.6. This x value over 2. I'm going to obtain the value that I have to increase. Okay, I'm to obtain the value that I have to increase. When I increase from this at this amount of area, I'm going to obtain 11556. Okay. Now I'm at this point, and I'm going to decrease at this amount of area. When I decrease at this amount of area, oh sorry, where's my curve? I'm going to increase at this amount of number. So when I increase and I reach this point, and this will be 115.56, okay, and I'm going to decrease at this amount of area, and I'm going to reach 187.2. For the second part, I have a moment. Look at here. I have a moment minus 187.2 as a moment. So I'm going to start the bottom of the line, 1872, okay, and then I'm going to increase at this amount of area. When I increase at this amount of area, I'm going to obtain 62.5. This amount of area. When I increased by this amount of area, I'm going to subtract from the 187.2. Then I'm going to decrease by this amount of area, and I'm going to obtain 122.4. And this is going to be the moment diagram for the second part. This is B, this is C, this is A, and this is B. Okay. Now the question is that if you like and if you want to see more of the videos, please subscribe and share with your friends. If I did anything wrong, please warn me and comments. I am going to check, and whether if I did wrong, I am going to make it better, fix it. Thank you for watching me. See you for the next question.